Hey guys, it's Mrs. Bothers. I am back again. And in this video, we are going to explore how to solve and graph one-step inequalities. So we have learned about inequalities in the past as far as how to look at a situation and write the inequality and graph the inequality, but we haven't really looked in depth at solving. So we're going to look at solving one-step inequalities today, and later this week we'll move on to solving multi-step inequalities. All right, so we're going to take a look at your MSG page, let's see, I think it is 9. Yes, page 9 in your MSG. All right, so let's go ahead and take a look at that. And I would also like to give a quick birthday shout out. Let's see, Marcus and Julian both had birthdays last week, so hopefully you guys enjoyed those. And Liana and Kaylin, you guys both have birthdays this week. So happy birthday to all of you 4 guys. I hope y'all, again, have a good time. All right, so inequalities, like I said, we're going to look at page 9 in your MSG, but I want to just start with a quick overview. All right, so remember an inequality, if you break the word down, the root word is equal, the prefix is n, and equal means not equal. So an inequality is basically a mathematical statement that shows quantities that are not equal. And they use those symbols, we've used those in the past, greater than, less than, greater than or equal to, less than or equal to, or not equal to. Okay, and we've looked at graphing those before as well. So remember, if it's just greater than or less than, when you graph it on a number line, you graph it with an open circle. Okay, and that's indicating that that value is not part of the solution. Okay, because it cannot be equal to that number. If the greater than or less than sign has a line underneath, that means or equal to. So this is, let's see, let me zoom in a bit, greater than or equal to, or less than or equal to. When you graph those on a number line, you graph those with a closed circle, indicating that that number can be part of the solution set. Okay, and then not equal to, it's just equal with a slash, so it's kind of self-explanatory. So it just means it can be any value except for that number. So when you graph it on a number line, it's an open circle, again, indicating that that number is not the solution. But if it's not that, it's saying it can be anything else. So you would shade both less and greater, so left and right. All right, just a couple of other things you need to know. A solution set is the set of numbers that makes any statement, or in this case, we're looking at inequality, true. So when we solve an inequality, which is what, like I said, we're going to look at today, you're solving to find what that solution set would be. Okay. If you're given an equation, you're looking at typically just one solution. But with an inequality, you're looking for an entire solution set. Because remember, an example might be x is greater than 3. Well, there's not just one solution to that. If your solution set is x is greater than 3, your solution set is every number greater than 3. So 3.5, 3 1/4. Kind of going backwards there, but 4, 5, 6, 1,000,000, 1,700,432.5. Okay, so a solution set, excuse me, is actually going to be an infinite set of numbers that would make an inequality true. And that's what we're solving, or that's what we're trying to find when we're solving an inequality. All right, so looking at page 9 in your MSG, okay, I've broken this page down so that, let's see, the first half we're just looking at inequalities that deal with addition and subtraction. Then we'll move on to multiplication and division. There is one difference between addition and subtraction and multiplication and division, one major difference when we're solving inequalities. So let's look at the basic stuff first. So if we're dealing with a one-step, okay, addition or subtraction inequality, basically you would solve for that variable, or basically the same way you would do with an equation, okay? So you've got 2 examples you can refer to here. So just to explain what this is showing, if our inequality is x minus 12 is greater than 32, we're trying to figure out what x equals. So just like you would with an equation, you get rid of that minus 12. So the inverse of subtracting 12 is to add 12. So you add 12 on both sides, leaving it with x. And then on this side, you have 44. So your solution is x is greater than 44, which means any value that is bigger than 44 would be true if I plug it in back here in the original inequality. So for instance, I know the number 45 would be true, okay, in this answer. So if I want to check to see if this is correct, what I can do is I can substitute 45 and up here to the original inequality. 45 minus 12 is going to give me 33, and 33 is greater than 32. Okay. I could also try another value, maybe something that's not true, just to make sure. So for instance, I know 40 would not be true as x because 40 is not greater than 44. Okay. So if I substitute 40 up here, that also should not be true. 40 minus 12 is going to give me 28, and 28 is not greater than 32. Okay, so that's kind of how you would check an inequality. It's going to be a little bit different than checking an equation. You still would plug in a value into the original statement. But with an inequality, I would always recommend choosing at least two values, maybe one that's true and one that's not true, just to make sure that they both work. Okay. All right, so let's go ahead and try the ones at the bottom on the left side of page 9. Okay, so as I said, you would solve it the exact same way you solve an equation. So if that was an equal sign instead, okay, what we would do is we would do the inverse of subtracting 4. So we're going to add 4 on both sides of the equation or inequality. And on this side, I'm left with my variable. On this side, -1 plus 4 is 3. So, and my inequality symbol, I need to put that back in my inequality. So that was less than. So my solution is x is less than 3. All right, I do want to check it. So I'm going to substitute a value back into the original inequality. For instance, let's say I use, let's say 2. Okay, I chose 2 because 2 is less than 3. Okay, so 2 would be true in place of x. I could have picked 1. I could have picked 0. I could have picked 2.5. Any value that is less than 3 should be true in this original statement. Okay, so when I check my work, again, I chose 2, so I'm going to put in 2 minus 4 is less than -1. Well, if I work this out, 2 minus 4 is the same as 2 plus -4. So that's -2 is less than -1. I know that's true. So this answer here is true. Now it also says to graph our solution set. So when we graph it, I may need to write these on a separate sheet. And you might need to too. When we graph it, I need to make sure that this 3 is on my graph. It's not including 3 in my answer because it's just less than. So open circle on 3 and I'll shade to the left. Okay. So again, what this is saying right here is that since it's an open circle on 3, it's saying 3 is not part of the answer, but I'm shading to the left, and to the left, all the numbers are getting smaller. So any value smaller than 3 would be true. Okay. All right, let's try number 2. On number 2, the inverse of adding -8 would be to subtract -8. And guys, think about that. If I'm subtracting -8, that's the same thing as adding 8. So I'm going to add 8 on both sides of the inequality. Okay. All right. On the left side of the inequality, this cancels out and gives me 0. I'm left with m. Write down my inequality symbol. M is greater than or equal to, and I have 10 plus 8 is 18. So my answer is m is greater than or equal to 18. All right. To check it, I'm going to substitute. This time I'm going to actually pick that number. So let me pick 18. If I put in 18 up here, 18 plus -8 is greater than or equal to 10. Okay, well, if I check that out, 18 plus -8 is 10. 10 is greater than or equal to 10. Okay. All right, and as I said, it's a good idea to choose 2 values, not just one, to check an inequality. Focus that. Okay. It's a good idea to choose 2 instead of just one answer. So let's say I also picked, let's see, what's another value greater than 18? 20. Okay. If I put 20 up here in place of m, 20 plus -8 is going to give me 12, and 12 is also greater than or equal to 10. Okay. All right. Number 3. All I'm going to say on this one is, again, be careful with your math, with the negatives. All right. So on this one, the inverse of subtracting -1 would be to add -1. So we'll add -1 on both sides of the inequality. That gives me z. And 1 plus negative 1 is 0. Okay, keep my inequality symbol. So my answer should be z is greater than or equal to 0. So basically the set of all whole numbers. Okay, because whole numbers are 0. Well, no. I can't say that. It's not all whole numbers. And think about that for a minute. Okay, why would it not be all whole numbers? And that's because this could be any, it would be the set of all positive answers, zeros and positive, because it can't just be whole numbers, it could be fractions and decimals. All right, so anyway, z is greater than or equal to 0. I'm going to check it by choosing a value that would be true in this inequality. So let's say 1. So 1 minus negative 1 is greater than or equal to 1. 1 minus negative 1 is the same as 1 plus 1. So 2 is greater than or equal to 1. That's true. Okay. So my solution is 0 is greater than or equal to z. Or sorry, z is greater than or equal to 0. Hold on 1 second. Okay, back to it. All right, so on number 3, when we graph our inequality, we've got to make sure, of course, 0 is on the graph. I'm just going to put negative 1 and 1. And since z is greater than or equal to 0, I'm going to put a closed circle on 0 and shade to the right. Looks like I forgot to do this on number 2. On number 2, when you graphed it, you would have had a closed circle on 18, and you would shade to the right because it was greater. All right, now let's look at number 4. All right, we have k plus 3 is greater than 0. So subtract 3 from both sides of the inequality. And I have k is greater than, and that's negative 3. Okay, we'll check it. So again, choose any value that is going to make this true. So if k is greater than negative 3, I could choose, let's say, negative 2. Okay, so if I have negative 2 plus 3, okay, negative 2 plus 3 is 1, and 1 is greater than 0. Okay, when you graph that on your number line, you would have an open circle on negative 3, and you would shade to the right since it's greater. Okay, all right, now we're going to make the switch on over to multiplication and division. Okay, so there's a significant difference here, and it's important that you guys remember that, first of all, you still solve the variable just like you would with an equation. However, the difference with this is anytime you multiply or divide both sides of the inequality by a negative number, you have to reverse or flip the inequality symbol. All right, so let's take a look at the example that's on your MSG page already. So we have negative 3n is greater than 12. Okay, so to solve for n, we would need to divide both sides. Since this is multiplication, we would need to divide both sides by negative 3. So divide by negative 3, and our solution is going to be n, and 12 divided by negative 3 is negative 4. We flip that symbol, so our solution is n is less than negative 4. Now let's test that out. Okay, so for this to be true right here, as I said, the solution is all numbers less than negative 4. So for instance, negative 5 would be a solution. If I plug in negative 5 right here, negative 5 times negative 3 is 15. 15 is greater than 12. Okay, if I were to choose, we'll say negative 100. Negative 100 times negative 3 is 300. 300 is greater than 12. Okay, so you can see that this is true. Now let's say we didn't flip the symbol. Let's say instead that we left it as greater than. And so let's say our answer was n is greater than negative 4 instead. Well, then when you, in fact, let me write that over here. When you choose a number to check your answer, let's say we pick 0, because 0 is greater than negative 4. Well, if I plug in 0 right here, 0 times negative 3 is 0. 0 is not greater than 12. So we would know that that can be correct. Okay, another number, let's say we chose negative 3, okay, because negative 3 is also greater than negative 4. Well, if I plug that in here, negative 3 times negative 3 is 9. 9 is not greater than 12. So you can see that it works, although I'm sure you're probably, thinking, why does it work? Okay, is it just some weird arbitrary rule that some random mathematician made up? No, there's a reason. Okay, so let me see. The reason that this works, and hold on. Okay, so the reason this works, as far as why we flip the symbol when multiplying or dividing both sides of an inequality by a negative, the reason this works is if you're multiplying both sides, they're both becoming the opposite. In fact, let's look at this with actual numbers instead of variables. We know that this inequality statement right here is true. Okay, we've known that since like kindergarten or earlier, probably 3 is greater than 2. Okay, but if I were to multiply both sides by, say, -1, those would become -3 and -2. Okay, so if I multiply both of these just by, like I said, -1, I have -3, -2, so they've become their opposite. Well, the numbers are opposites. This whole statement would have to become the opposite. So instead of greater than, that's going to become less than. And we know that this is true. -3 is less than -2. Another example, if I had, say, 1 is less than 5. Okay, if I multiply both of these values by -1, I get -1 and -5. So since those are opposites, this also that whole entire statement becomes the opposite. So the opposite of 1 is -1, the opposite of less than is greater than, the opposite of 5 is -5. And again, we know that this statement is also true. -1 is greater than -5. Another example, if I look at, let's see, -6 and 3, okay? I know that -6 is less than 3, but if I multiply those both by -1, I get +6 and -3, so they're both opposites. And again, that's another example when I would need to flip the symbol, okay? And multiplication, division, just keep in mind they're inverses of each other. So it would be the same if I divided both sides by a negative value. So just keep in mind, anytime we multiply both sides of an inequality by a negative, we have to reverse that symbol, okay? So looking at page 9, all right, numbers 1 through 4. All right, we're gonna first solve the inequalities. And in fact, let me rewrite these. All right, so looking at the first problem, I have -3x is less than or equal to 12. So my first step will be to divide both sides by -3. All right, that's going to give me x. And notice, since I divided both sides by a negative, I know I need to reverse the symbol. So it's going to become greater than or equal to. And then 12 divided by -3 is -4. All right, and then I want to check this by just choosing a value that would be true in this final statement and substitute it up here into my original inequality. So a value that would be greater than or equal to -4 might be, let's say, 0, okay? So if I plug in 0 up here to the original inequality, let's see here, we check -3 times 0, okay? And so that is 0, and 0 is less than or equal to 12, okay? All right, and like I said, let's pick maybe a couple of different numbers. So let's also choose maybe one that's a little bit closer to -4. Now we know it could also be -4 as one of our solutions. I'm not going to use that one though, just because that's not going to prove whether or not the symbol is correct. Okay, so let me say -3. So if I choose, let's see, so second check here, -3 times -3, that's going to give me 9, which is still less than or equal to 12. Okay, so I've done 2 checks here. I used 0 as a solution and -3 because both of those would be true here. But both of those worked out, so I know that this solution is correct. All right, when we graph that, we know we're going to have a closed circle on -4. And since it's greater, we will shade to the right. Okay? All right, the second problem, okay? The inverse of dividing by 6 would be to multiply both sides by 6. So that's going to give me y. And then this is -36 times 6, which is going to give me -216. All right, here's where you have to be careful. All right, do we switch the symbol there? Okay, the answer is no. it stays the same. We do not reverse the symbol, and that's because we did not multiply or divide both sides by a negative. Another way to look at that is saying that the negative started on the same side with the variable. Okay, so yeah, we had a negative over here, but we didn't end up multiplying both sides by a negative. We multiplied both sides by a positive. So I don't care what was over here. Okay, the number that started on the same side as the variable was positive. We multiply both sides by a positive, so the symbol's going to stay the same. We only reverse if we are multiplying and dividing both sides by a negative. All right, so let's check our answer, make sure it's correct. So again, I'm just going to pick an easy value to use. So a value that's greater than -216. Again, I mean, I could use something like -215, but to me, something like 0 or 1 is easier. So if I plug in, let's say 0 divided by 6 is greater than -36. Well, 0 divided by 6 is 0. 0 is greater than -36. So I know that that's correct. Okay. If I chose another value and plug it in, it would still work out. So my solution is y is greater than -216. Okay. And oh, if I were to graph that, we're going to have an open circle on -216 and shade to the right. Okay. All right, number 3. On this one, I see n is divided by -9, so the inverse would be to multiply both sides by -9. All right, that's going to give me n. And over here, -3 times -9 is +27. All right, notice that we did multiply both sides by a negative. So in this case, we reverse the symbol. So our solution is n is greater than 27. All right, so to check it, I'm going to choose a solution that would be true here. So I'm just going to use, let's say, I'm dividing by -9. So how about 36? Okay. So if I substitute 36 up here, 36 divided by -9 is going to give me -4, and -4 is less than -3. All right, so if I were to plug that in, okay, I see that that's correct. If I chose another value, again, it would work out. All right, so n is greater than 27. I'd have an open circle on 27 and shade to the right. Okay, I'm noticing like all these almost came out to greater than. But just remember, greater than, shade to the right, less than, shade to the left. All right, number 4, 12x is greater than or equal to 72. Guys, there's no negatives on here at all, so we don't have to worry about reversing the symbol at all. We'll divide both sides by 12, and that gives us x and 6. The symbol stays the same, so x is greater than or equal to 6. I can check it by substituting a value that would be true here. So let's say 7. 12 times 7 is greater than or equal to 72. That's 84. 84 is greater than or equal to 72. So this is correct. That would be on your graph a closed circle on 6 and shade to the right. Okay. Let's see. All right, so I want to look at a few more of these. Just kind of quiz yourself. I just want to look at whether or not we reverse a symbol, because typically that's the main thing that people struggle with on this, not the solving, but just figuring out when to reverse a symbol. So on this one here, would you reverse it? Nope, you would not. And that's because it deals with addition. Okay, anything where it's only addition or subtraction, you don't have to worry about reversing the symbol. All right, what about the second one? That's a yes. Okay, because you would end up, you'd have to divide both sides by -6. How about this one here? Nope. This one? Nope. Again, because the number on the side with the variable that we would be multiplying both sides by is positive. Okay, so I don't care what's over here. I would not have to reverse the symbol there. The next one is a yes. Next one here would be nope. And the last one here is no. Okay. All right, guys, hopefully that helped you out. If not, as always, just shoot me an email. Or remember, I'm having the Zoom sessions each day. Actually, just kidding, not each day. It's like Tuesdays, Wednesdays, and Thursdays. I'm having the Zoom sessions from 11 to 12. So feel free to pop in at any time on any of those days. Or if that doesn't work, again, shoot me an email and I can probably do it any other time too. I'm not going anywhere. So feel free to let me know, and I hope you guys have a great day, and I will talk to you later.